Okay, so today is about solving exponential equations and log equations. Over these notes, and then you're going to do work to practice what we've learned. And the leap from what we already know to what we're learning today is pretty small, so we shouldn't have any issues. I know the video will skip around, but let's do the best we can. Okay, so that should get a little bit better. All right, here we go. Oh, let me turn that light back on. Sorry. Okay. So, what we're going to do, a couple different methods. So first of all, we're solving an exponential equation by getting the same base. Okay, this is, and we already know it. So just to review, looking at these two problems, they're exponents, and they can both be taken to base 3. Leave this one alone. And I rewrite 9 as 3 squared. And then I multiply it by whatever else was still up. And now, because I have the same base, I can set this equal to this. So I do. X plus 2 equals, don't distribute, 2x plus 2. Subtract the x, subtract the 2, x equals 0. Okay? All right, let's do it again. So we have 4 to the x plus 2, and I'm going to say change that to 4, but can I change that to 4? No, I can't. So what do I need to do? I need to change this 4 to a 2 squared, which then multiplies to what was already up there, and then the other side changes to a 2 to the 3rd power times x plus 1. Now I can set, they're both in base 2, so I have 2x plus 4 excuse me, equals 3x plus 3. And now I can solve for x. Subtract the 2x, subtract the 3. So that we already knew. Now, so we have this situation where we cannot change the 15 to a 2 to some power. We do. I'm calling the method isolate and rewrite. Okay, isolate and write. Okay, and what I mean is we're getting the exponent term by itself. Now, like in this problem, it already by itself, but in this problem, we've got 5 to the x plus 2 plus 3. So I need to get rid of that 3 first, and then I can rewrite. What do I mean by rewrite? I mean by using my equation, which is the log base b of y equals x, if and only if b to the x equals y, right? And going back and forth. So here we are. Let's go to the log. How would I rewrite that as a log? Well, I would say log base 2 of 15 equals x. Let's look at our arrows. The log base 2, 15 equals x. Now, this is just a number on my calculator. So I just take my calculator, math, log base, the log base 2, 15, 90, we'll round that to the 7th place. So 3.907 equals x. Remember, if you log base function on your calculator, you use the change of base formula, which is the log base n of 15 divided by the log of 2. Okay, next problem. I have to isolate first, so I subtract the 3 from both sides, and I get 5 to the x plus 2 equals 22. Well, now I isolated and I can rewrite it. Go to my equation and I say, okay, the log base 5 over here of 2 is equal to x plus 2. That is just a number on my calculator. So, log base, the log base 5 of 22 decimal, 1.921 equals x plus 2. Now I have to subtract 2, it's fine. Get x equals, I got 1.92 there, minus 2, negative 0.079. Equals negative 0.079. Right, so. Okay, so I want you to stop these two problems. Okay? All right, and we'll move on. Now, this top of the last page, when we could get the same base, we just set the exponents equal. Well, these aren't exponents, they're subjects of logs, but logs and bases are equal, then what else must be equal? Then x must be equal to 7. Log base 2x must be equal to 8, but then I have to solve. X equals 4. X plus 4 must be equal to 10, so I just solve. X equals 6. Okay, so that situation is if the log bases are the same, you may set the subjects of the logs equal to each other. Okay, moving on to property of logarithmic equations, which is basically what we just talked about. The log equation property is what we just saw up here. So when we have problems that involve logs that are fairly simple, log equation property, solve for x, but here's the new thing. We must check our solutions by substitution because we can never have a negative, we can never take the log of a negative number. So we have to check to see that our answer doesn't give us a negative number here, okay? So let's do log equation property says 5x minus 1 equals x plus 7. Subtract the x and I get 4x, x equals 2. Okay, now I have to double check. I have to check my solutions. So I put the 2 back in, so just check. All right, the log base 3 of 5 times 2 minus 1, is that equal to the log base 3 of plus 7? Okay, so we're just checking our answer, and we get the log base 3 of 10 minus 1 is 9. It's the log base 3 of 9. Now that is equal, and we could stop there, but we also could say 3, we could evaluate this. 3 to what power is 9? 2 equals 2, check. Okay? So, just using that property, which the only thing of is that we check it. So do these two problems and check it. This, by the way, is just a typo. Sorry about that. Okay, stop the tape, do those, and then we'll move on. Actually, I'm going to stop the tape, and you do those two problems, and we'll get to another for solving logs.